Picture this, a towering rocket, flames roaring beneath it, shaking the Earth as it claws its way into the cosmos. How does a 3,000-ton beast break free from Earth's relentless grip and soar into the stars? Today, we're diving into the jaw-dropping physics behind rockets, thrust, fuel, and the mind-bending dance of orbital mechanics. Buckle up, because this is going to blow your mind. Spaceflight isn't just sci-fi magic, it's raw, real science at work. Rockets don't just go up, they wrestle with gravity, harness explosive forces, and follow precise cosmic rules to reach orbit and beyond. In this video, we'll unpack how rockets defy Earth's pull, why fuel is their lifeblood, and how they pirouette through space like celestial ballerinas. By the end, you'll see why rockets are humanity's ultimate engineering triumph. Let's ignite this journey. Section 1: The Battle Against Gravity. First, let's talk about the enemy, gravity. Earth's gravitational pull is like an invisible hand, yanking everything downward at 9.8 meters per second squared. To escape this force, a rocket needs to hit a speed so blistering, about 11.2 kilometers per second or 25,000 miles per hour, that it can break free entirely. This is called escape velocity. But getting there? That's where things get wild. A rocket doesn't just need speed, it needs thrust, the raw power to push against Earth's grip. Thrust comes from Newton's third law: for every action, there's an equal and opposite reaction. When a rocket blasts hot gases out of its engines at insane speeds, it gets a kick in the opposite direction, upward. Think of it like blowing up a balloon and letting it go. The air rushes out and the balloon zooms away. Now, scale that up to a rocket engine burning thousands of pounds of fuel per second, and you've got a force that can lift a skyscraper-sized machine into space. Take the Saturn V, the beast that sent humans to the moon. Its 5 F-1 engines generated 7.5 million pounds of thrust, enough to punch through gravity's hold and send astronauts to another world. But here's the catch. Gravity doesn't give up easily. The higher you go, the weaker it gets, but it's always pulling. So, rockets need to keep burning fuel to maintain that upward surge until they hit the right speed and altitude. This brings us to the heart of rocketry. Fuel. Section 2. Fuel, the rocket's lifeblood, 3 to 6:30. Rockets are hungry. They guzzle fuel like nothing else on Earth. But it's not just about quantity, it's about chemistry. Most rockets use a combo of a fuel and an oxidizer, together called a propellant. The fuel burns, but it needs oxygen to keep the fire alive. In the vacuum of space, there's no air, so rockets carry their own oxidizer, like liquid oxygen or nitrogen tetroxide. When these two mix and ignite, boom, a controlled explosion. For example, the space shuttle's main engines burned liquid hydrogen and liquid oxygen, producing water vapor and a whopping amount of energy. This reaction is so intense that the exhaust shoots out at speeds up to 10 kilometers per second. That's what gives rockets their punch. But here's the kicker: fuel is heavy. The more fuel a rocket carries, the more thrust it needs to lift it. This is where the rocket equation comes in, cooked up by Russian scientist Konstantin Tsiolkovsky. It says the amount of speed a rocket can gain depends on how much propellant it carries and how fast it can shoot it out. The catch? To go faster, you need more fuel, which makes the rocket heavier, so you need even more fuel. It's a vicious cycle. That's why rockets are staged. Picture a rocket like a layered cake. Once a stage burns through its fuel, it's dead weight. So, the rocket sheds it, dropping empty tanks to lighten the load. The Saturn V had 3 stages. The first got it off the ground, the second pushed it toward orbit, and the third sent it to the moon. Each stage was a mini-rocket, perfectly timed to maximize efficiency. And modern rockets, like SpaceX's Falcon 9, they take it further. They reuse stages by landing them back on Earth, slashing costs and making spaceflight almost routine. But fuel and thrust only get you off the planet. To stay in space, you need to master the art of orbital mechanics. Section 3, Orbital Mechanics, the Cosmic Dance, 6:30 to 10 o'clock. Once a rocket clears Earth's atmosphere, it's not just about going up, it's about staying up. This is where orbital mechanics steals the show. Getting into orbit isn't about escaping gravity entirely, it's about moving fast enough sideways that you keep missing the Earth as you fall. Imagine throwing a ball. Throw it softly, it arcs and hits the ground. Throw it harder, it goes farther. Now, throw it at 7.8 kilometers per second, about 17,500 miles per hour, and it'll curve around the Earth without ever hitting it. That's an orbit. Rockets aim for the sweet spot, called low Earth orbit, or LEO, around 200 to 2,000 kilometers up. But orbits aren't just set it and forget it. They're a balance. You're constantly falling toward Earth, but your sideways speed keeps you circling. This is why astronauts in the International Space Station float. They're in free fall, but moving so fast they never hit the ground. To reach higher orbits or head to the moon, rockets use a trick called a Hohmann transfer. It's like an elliptical racetrack. You burn your engines at just the right moment to stretch your orbit, slingshotting you to a higher altitude or even another body, like Mars. Timing is everything. Miss the window and you're wasting fuel or missing your target entirely. And then there's the ultimate challenge, escaping Earth's gravity completely. To leave for deep space, you need that escape velocity we mentioned, 11.2 kilometers per second. Once you hit that, you're free to explore the solar system, but you'll still need precise burns to navigate the vast cosmic highways. Section 4. Why it all matters. So, why does this matter? Because rockets are humanity's bridge to the stars. Every satellite, every Mars rover, every astronaut who's ever gazed at Earth from space, they all got there because of these principles. Thrust overcomes gravity. Fuel powers the journey. Orbital mechanics charts the path. Today, companies like SpaceX, Blue Origin, and NASA are pushing the boundaries further. Reusable rockets are slashing costs. Missions to Mars are no longer dreams, they're plans. And maybe one day you could be on a rocket looking down at our blue planet thanks to the physics we just explored. Wow, what a ride! If this dive into rocket physics blew your mind like it did ours, smash that like button to show your love for science. Subscribe to our channel for more mind-bending journeys into the cosmos and hit the bell so you never miss an upload. Want to geek out more? Drop a comment with your favorite rocket fact or what space topic you want us to tackle next. Stay curious, stay inspired, and let's keep exploring the universe together. See you in the stars.